Hi, nice to meet you all. I'm Fiona. I'm a consultant and a developer with Thoughtworks. And today I'd like to have a chat about the social implications of bias in machine learning. Before we kick off, I'd like to define those terms that I just used. In particular, I want to talk about what I mean by social bias and then also what I mean by machine learning. So let's talk more generally about bias. I've got some quotes here about real-world bias. So I won, so gambling must have been a great idea. Outcome bias. I've got, there's a large man walking alone at night. He must be dangerous or scary. This is stereotyping, which can cause us to have fractioning in our society. We've got, people often say mobile phones cause cancer, so they must. This is groupthink, or this kind of thing could lead us to have incorrect assumptions. So there's bias, it can cause problems, but what I'm talking about specifically in this talk is social bias, and what I'm not talking about is statistical bias. The reason I make that distinction is because in a lot of machine learning literature, or when we're working in this industry, statistical bias is often mentioned, but I just want to talk about the fact that that's not what I'm talking about. What I mean is social bias, so that's some kind of prejudice, whether that be conscious or unconscious, against a group based on their attributes, maybe race or religion or sex or something. Statistical bias, the thing I'm not talking about, that's when we have a lot of different measures that we've taken and we've averaged them. The difference between that and the actual thing we're trying to predict. So that's the thing that I'm trying to stay clear of. Now, we can definitely see how bias could be problematic, but really it's also necessary because the world is so full of all of this information, we can't possibly process and consider every single element for every decision we make. We need to take shortcuts, but these shortcuts can be problematic if they reinforce something in our history or society that we don't want to reinforce. The other thing I want to define quickly is machine learning. So at least in the context of this, I'm going to use the terms algorithm and statistical model pretty much interchangeably. And by that, what I'm talking about really is something that performs a specific task. So a computer system that performs a task, not generalized AI. And I'm also talking not just about a bunch of if-else statements, like wrapped up as ML, but actually something that uses patterns and inferences to determine some prediction. I'm sorry if this is really your bread and butter and you're doing this all the time, but just in case there are some in the room who are less familiar, I want to quickly define machine learning a bit deeper. So what would the ingredients look like? We would have a question that we want to answer, some data, ideally relating to that question. We would have then a model that we generate, let me skip it for now, and then some test, some smaller section of that data that we use to determine whether this model could actually accurately answer that question. For a deeper example on this, let's say the question was, what's the likelihood of us hiring a candidate? We might have data relating to resumes and who was hired. Then we would generate some kind of model based on the relationship between those two data sets and come up with some prediction about whether someone will be hired. For another example, these are two pictures of cats that I took. In order to find them for this presentation, I got out my phone and I was just looking through my Google image library, and I was thinking about cats and remembering interacting with them. They're soft, usually inside, this kind of stuff, and I was able to try to find some cats, but that was a bit tedious. So I just typed cats into the search bar at the top, and Google instead found these two pictures for me. But how did Google's algorithms find these pictures of cats? It can't apply the same thinking that I was applying to find them. It's only got a 2D array of pixels to work with. It doesn't have any context about what a cat is. So it probably used something like this. It got a bunch of data in the form of pictures of cats and pictures of not cats, and then was able to feed that in to generate a model that could tell me if it's a cat or not. But even the people who developed this, who trained that model, they wouldn't be able to tell you the 7th pixel from the left on the second row, how does that impact whether or not I think this is a picture of a cat? How would they know this? So what I'm getting to, I guess, is that it's kind of a black box. There's definitely ways we can influence it through the data and through training and seeing whether it makes sense or not. But observability is something that is almost a trade-off. It's not quite this simple. But when we get a more complex model, we are likely to lose observability on how it actually functions. And therefore, we don't really understand how it knows it's a cat or doesn't know it's a cat. So it's about these two factors, really, and sometimes we want accuracy so much that we go with something so complex that we ourselves can't really grasp it, and therefore we lose that observability. So how's this talk going to go down? Well, I want to take us through on a journey through all of those stages, starting right from the beginning with data, going through to the generation of a model, and ending in the usage of that tool. And I want to try and show some examples of how this could be potentially not great for society, but also mitigation strategies against those risks and potential ways that we could improve things and make it neutral or positive as an impact. So let's see how we go. Starting at the very beginning with data, that's sort of where it all leads from. We need to be careful when collecting data, because as much as people like to say that data is this sort of pure, unadulterated, unbiased thing that just exists and is, it really isn't. And the data we might happen to have lying around, we don't know who collected it, when, and why, and with what intent. For instance, if someone asked you about your earnings, for instance, and that person was maybe a friend who's in financial trouble, or someone you're dating, or the tax office, you might give a different answer. So it might matter who collected that data and when. To give an example, Boston found they had a lot of potholes in the city, and they wanted to work out which ones should we prioritize fixing. So they developed this cool app that uses the accelerometer in the phone and also the GPS. And you place it on the passenger seat, and you get to find out if you go over a pothole, it registers there was a pothole there. Awesome. But then it seemed to show that there's a lot of potholes in really rich suburbs, which they found odd, until they started installing this app on garbage trucks and public buses. And suddenly they discovered, there's a bunch of other potholes in other parts of the city that we didn't know about. And it was because the people using the app were usually very wealthy people with private vehicles and a spare seat who didn't have to worry about their phone battery. And these people were collecting a specific subset of the data. So that was an important discovery to have. So the data doesn't really speak for itself, as people often claim, but really it does echo its creators, the people who actually collected it. Its collectors will come through in the data we end up with. I really like this quote. Data being raw is an oxymoron and a bad idea, so we should cook it with care. So cook as in to make something not raw, but with intent. I think that's really important. It's common in machine learning to talk about this concept of garbage in, garbage out, and I think the same thing could be said for bias in, bias out, because that data is all that machine knows. Whatever is in there is what's going to come out. But what can we do about this? Well, one thing is we can really critically think about the data we're collecting and how it's being used. One tool for that is this Open Data Institute have made something called the Data Ethics Canvas, and it's got a lot of really interesting questions that you can ask yourself in your teams. One of them talks about, one of those boxes, talks about the negative impacts that it could have on people. It asks questions about, could this cause harm? Could it be used to segregate a group? Could it unfairly treat certain groups? Could people perceive it to be harmful? Because in some way, perceptions are reality. It also talks about minimizing negative impact, and in this set of questions, it also asks about how you could measure the impact being made by your model, and therefore maybe mitigate it if necessary. So let's talk about how data is collected. Let's make sure that's a conversation we're having in our teams. Let's be skeptical of what data exists. It looks easy to use, but it could mislead us. And there are some tools, including Ethical OS, have a similar set of questions that we can use to help have those discussions so we don't miss things and not consider them. The next thing that might be worth focusing on is filtering of misleading data. So once we've collected our data with only the biases that we know about. What can we do to filter out what we shouldn't keep? And you might say, why would I filter data? Data is powerful, more is more, but let's talk about it for a little bit. So there was historically mostly men involved in orchestras. And this was because a lot of men were trained to be musicians, like hundreds and hundreds of years ago. And so, of course, orchestras were mostly men. But this continued even after the point where plenty of women were very well trained at playing instruments. And people wondered why. And so what they started doing was closing the curtain during the auditions so that the people judging couldn't tell the gender of the person playing the instrument. And this was meant to solve that problem, but it didn't. Somehow the ratio in the orchestra was still the same. People wondered why. And then they realized that when someone who presents as female enters the stage, her heels are probably going to go clip, clap, clip, clap, clip, clap. And people will know. In the back of their head somewhere, the judge realizes the gender of the person. So they just asked everyone to take off their shoes. And suddenly, women could play instruments. There was diversity in the orchestra. It was incredible. So sometimes having less information is actually going to give you more accuracy, because the idea of an orchestra is people who play instruments well. These are known as the protected attributes. There's an Australian law that's been around longer than I have that says all of these things cannot be considered in any hiring, firing, or promotion type decision-making. I looked up the same laws in Germany when I moved there, and they have very similar laws that say none of this should be considered legally in terms of hiring decisions. But what if we were creating some sort of algorithm that helped us to filter applicants, like we mentioned earlier? We also need to make sure it doesn't consider these either, or the proxy values to these. But what's great about machines is that they only know what we tell them. And if we tell them to forget something, it's deleted, it's gone. Humans are much less capable of this. And so in some ways it's actually more powerful if we can get it right, because we can intentionally exclude information which we don't want to consider. So it can be difficult sometimes to let go of something, because it sounds impressive when you have a lot of information, and I know you've already collected this data, but it could actually lead to a less accurate decision. So the legal constraints are worth considering, and potentially the reason those laws exist, the morals behind that, as well as can we reduce, what can we delete in order to get a better outcome? And then forgetting being difficult for us, but something that machines do really well. So can we leverage that? So part 3 of our trilogy on data, we've got adding of missing data. What do I mean by that? Well, when we're raising machines, just like the way we raise people, we want them to exist for now and for the future. But what we've got currently is information about the past. But we still know where we want to go. So when we're raising a child, let's say we said to our child, oh, we should go to the doctor because you're sick. We'll go to the doctor and see what they think. We probably wouldn't say, let's go to the doctor and see what he thinks, because we don't want to make our daughter imagine she can't be a doctor as well. And so even though our historical context of doctors might be mostly male, we would probably want to pass on to this new person who's going to go into the future what we think they need for that future. So if I asked Google Translate, and this is me, you can see my avatar on the top. If I ask Google Translate some questions about translating sentences about occupations, I've picked Malay as the language. Can be read, cool. And I picked Malay because it's got these 2 words that mean they are. And it doesn't mean they as in a group of people, it means one person. They are something. And I then asked it to translate these into English, and you can guess the result based on the fact that I've included it in this presentation. It decided to say that he is a doctor and she is a nurse. And this is still the behavior of Google Translate, though they have worked, and I'll show you later their solution to this. But I can understand why this is the case. Because if I was trying to build this product, I would want to collect as much data as I could about all the different times that I've seen this word and this word together, and I would have more examples of he being a doctor and she being a nurse. So of course I would get this. But could there be ways to maybe weigh more recent data more heavily? Maybe there are ways to feed into this algorithm both all of the data I have and all that data again, but with the pronouns swapped. Could I do these kinds of things to end up not reinforcing patterns I don't want to reinforce, and not making an inaccurate product that doesn't represent the future? So what Google have done is, sorry, now I've swapped to Turkish because they've handled this for Turkish, is they just show multiple translations. So this is one nice solution. They've noticed this problem and started resolving it. Because really, if we look at the data on this, we are heading towards parity between the number of male and female doctors. So this is going to soon be a product that really has the wrong answers. And it doesn't really give you what you want to know, which is the definition of the word. It instead tells you a little bit about the society of English-speaking nations. Someone else I want to introduce you to, this is Joy. So she's a researcher with MIT Media Labs. She's an AI researcher, and she did her master's thesis about facial recognition technology. And what she talked about was how accurately facial recognition software works on people based on both gender but also race. And she found that the group that it was least able to recognize the faces of were women of color. She was working on an art project, and that's when she discovered that this might be an issue. I would love to share with you her experiences. I don't know if this will work.
The system I was using worked well on my lighter skinned friend's
not working on her face,
but when it came to detecting my face, it didn't do so well.
Until she wears a mask.
Until I put on a white mask.
So I think this is just a really good example of how problematic this can be and how this could have impacts on society. And she advocates really strongly in her advocacy work for diversity in teams. This has already been proven to help out with things like it has better financial gains, it has better decision making, but also if we've got people with more different experiences of the world, that variety can help us to see who is missing from our user set, who we're not considering. If we don't have this, for some reason, we could consider using tools like the tarot cards of tech. This actually recently made it onto the Thoughtworks technology radar in the assess category for techniques. And I really like it. It talks about how we need to consider who those people are who we might have forgotten. So it's already admitting that we're probably missing someone, and we're aiming to try and find out who those people are. One suggestion I liked was to think about why those people might give a product a 1-star review. Because if we want to avoid 1-star reviews, let's try and preempt the problems that might exist. Another cool tool is Facets. This is by Google Pair Initiative, which is their people and AI research group. They made this and another similar product which helps to analyze the data set and just see, in this case, this is some census income data, and it mostly represents professional white married men. So if the predictions that this data was driving were about that group, probably that would work really well. But if it wasn't, then maybe there's something missing and we can highlight it and then discover that data before we make these mistakes. Cool. So sometimes things aren't fit for purpose, like they can't detect a face when they're meant to detect a face, until we add the missing data, and that would solve it. Diversity in teams is one approach to this, or at least considering a diverse population. And Google have a few cool products. This is not sponsored, but they have a few cool products, Facets and Facets Dive, to look at this. Observability and justification is another category I'd like to discuss. In particular, the GDPR recently brought out something that, in the legislation, that's being called the right to an explanation. That's the simplification of this, Article 15, which says that the person who some data is about, they're calling this person the data subject, should know if automated decision-making was applied. So we need to tell users in this jurisdiction, hopefully future jurisdictions as well, we need to tell these users if data is being used in this way about them to make a decision. And we need some explanation of the logic involved. So this is where we have to start opening the black box. As well as that, they also asked for us to provide some kind of idea of the impact this decision could have, which means that the teams involved also need to consider this, which I think is excellent. So how might we go about opening that black box? Because we don't want to limit ourselves in the algorithms we have available. We don't want to only be able to pick a really simple, observable approach, because we might lose out on accuracy. And why else, in spite of those legislations, if they don't apply, why else might we want to know? Well, if we don't know how something works, can we really trust it? Just because it seems to test well, if we don't really understand how those decisions are being made, I don't know if I would trust it necessarily does the right thing for the right reason. So Lime is one approach. Lime is both a research paper and a Python library, if you like to pip install things. This is something you could pip install later. But I'll explain what Lime is. So it's this local, interpretable, model-agnostic explanations. That's a mouthful, starting from the bottom and working our way up. Explanations, as in it explains why a decision was made. Model-agnostic, doesn't matter, is it a random forest, is it a neural net? Whatever the approach is, this can be applied. And I guess by interpretable, they mean people can actually understand the output of it. So we can grasp what it means. And then local to the area where the decision is made or the distinction in the prediction comes from. I'll show an example. So this is a picture of a tree frog. Well, it's most likely a tree frog. But we don't know why did this algorithm decide this is a tree frog. What we can do with Lime is we generate hundreds of thousands of permutations of that tree frog image where we just toggle off some of the pixels. And what this gives us, when we look at whether they are tree frogs or not, is an idea of which clusters of pixels actually impacted that decision, tree frog or not tree frog. And this can give us an idea of where the boundaries are around the sections of the image and an explanation. This was the part that made this a tree frog. And that's pretty amazing. Of course, this works for things that aren't pictures as well, but this is just more visual. If that's too much code, there's the What If tool by Google Pear and a similar thing which kind of implements Lime in IBM's AI 360 fairness framework as well. So there are other alternatives. But really, I think this is really cool because if we can see how a machine made a decision and we get that observability, then that's kind of more powerful than people when they make decisions. If I ask you why you chose something, you might think of a post hoc justification, but really the likelihood that even you have that grasp of how you made that choice, maybe we don't always. So in order to trust the models we're making, we kind of need to understand why they do what they do. Lime is one way to open the black box and get that insight. And there are also other tools. So there's plenty of options. I want to touch briefly on feedback loops. So Facebook recently got in the media again about the way they were showing ads to the users. So when you post an ad that you want to show on Facebook, you can specify what group you would like to have see that ad. And then later on, you can access data about which group did see the ad that you showed. What people were seeing was that the people who ended up seeing their ads seemed to really follow those stereotypes that you would imagine. So based on the race or the sex of the person, they were more or less likely to see an ad about things like job applications or about housing and things that really matter to people's lives. And this was less than ideal because that can lead to a different outcome. Now, we've already talked about how data leads to a model which leads to a decision. But what about when that decision leads to some outcome, like who shows up to a job interview? And what about when that outcome leads back into the data that trains the next model? Then we just start automating the bias that already existed. So really, it's more dangerous than just whatever the thing is that we're working on right now, because we are impacting the future. It's not just code. And that will become the data of the future, and therefore what people will train their next models of. One example from the US, predictive policing as well as determining of bail was being done with some automated decision-making tools. And this could be impactful to people because the more we look, as in predictive policing, the more we look for something, the more likely we are to find some problems. And the longer someone has a sentence in what kind of harsher jail with harsher criminals, that's also likely to impact that person's outcomes. So there's a tool called Compass, and an organization called ProRepublica came and had a look at this tool and the data, which they've posted online, and I'll share it with you as well, where they looked at two categories. They looked at people who are white and people who are African Americans. And they looked at two things. One is someone who was determined to be high risk of reoffending, but then didn't actually reoffend. So that's one kind of false positive. And then people who were considered low risk of reoffending, but actually reoffended. So these are false negatives. These are the two categories we want to try and measure to avoid. And what they found was that for white people, it was much more likely to assume they weren't going to reoffend even if they did. And it was the inverse when looking at African Americans. And this is still used, this product. So as often is the case, this meme kind of says it all. Yeah. Do you want to reinforce stereotypes and discrimination? Because that's how. I want to find a silver lining here. I mean, we know that juries are not perfect either. And maybe if we look at the previous sections, the idea of getting observability, we can make this a better place. So today's outputs are tomorrow's inputs, and this is worth considering. What are the patterns that we want to reinforce actively? Because in some ways we have the power to potentially make things better if we're reinforcing the things we intend to. Last but not least, usage and governance. There are a lot of other industries, for instance pharmaceuticals, who have come before. They've faced problems, they've found potential solutions. For instance, when you buy medicine from the pharmacy, it will have listed on it, this is what it's capable of doing. These are the things it can't help with. It'll tell you the active ingredient that makes it work. It'll explain to you how to use it and when to use it. It will have safety measures like this cool cap that children can't open. It'll have a product recall if they find out it's actually harmful or even just not effective. Could we not apply the same kinds of things to a model, or maybe even any software product, to avoid it being misused, but also to avoid people assuming it's perfect just because it's a machine, it's based on maths, it's got to be right. It's really just made by people, and it will have its own limitations. So if we can be more transparent about that, then people can use it with that knowledge. There were some pretty cool headlines, more than a year ago now, about how 28 members of the US Congress had been matched to mugshots of criminals by a facial recognition software by Amazon. And in Amazon's response to this, they criticized this test, saying that they had only used the 80% threshold for confidence, which is the default. I would question whether 80% is an appropriate default if it wasn't okay to use for this test. I know that Amazon do provide this as a service to law enforcement organizations. I would hope that when they do, they set a different threshold nearer to the 95% that they suggested in their press release after this happened. But I can't know. So in response to this, some parts of the world stopped using it. San Francisco have decided, like a week or two ago, that they're no longer going to use this for law enforcement. Orlando police stopped last year, and Microsoft have called, please regulate us. When an industry asks you to regulate them, you know maybe something might be up. So in any other industry, when we develop something that we determine is harmful, we don't release it. We keep that to ourselves. Why would this be any different? A great example of a group that did the right thing on this, I feel, is OpenAI. As their name suggests, OpenAI do AI research, and then open it up. But recently, they didn't open up something that they discovered, because what they had discovered was a way to generate text that was really believable that a human wrote that text. And they were quite worried about what impacts that might have on the world, particularly since we'd just recently had some technology that could create really believable human faces. And they thought about how those technologies combined could be hugely impactful and probably not positive. And so what they did instead was they only released a small cut-down version. They started a conversation about the problem, and I think that was a really great approach on their part. Again, something that technology has that we struggle with is this ability to roll out something new really quickly. You can push code into production much quicker than I can push out a person, raise them to be better than myself, and push them into society. What changes were generational, especially in terms of unconscious bias. If we can properly automate them, then we can push out much quicker results than we can with generational change in humans. So can we inform users, warn them, and sometimes restrict them so that they use our products in the way that we intend and want? Are there ways in which we can demand better products and, as technologists, help to try and encourage sensible governance of these technologies? And unlike with humans, can we push out faster change in an intentional direction that we want to move? So to summarize all of that, data is never free of bias. It's more about being aware of what biases exist, because we don't want to just fix the potholes in rich suburbs. Let's be conscious of exactly what information we feed into a machine and realize that we have the benefit of choosing what it knows. Let's try to put up the curtain and take off the shoes so that we hire the best musician for the orchestra. Remember when Google Translate said that he was a doctor and she was a nurse? Remember when Joy's face couldn't be viewed by the facial recognition software? Can diverse teams help us in making sure that we don't leave people behind and have them be forgotten? Are we creating products that lead to the future that we want, or that just represent the past we had? Can we use tools like Lime and others to open the black box, not just for ourselves, but to provide explanation to our users as well? When we create outcomes in the real world, they impact the data that we want to rely on later. Let's be intentional in the kind of feedback loops that we're creating. And can we learn from other industries who have already made mistakes and had horrible experiences in the media and not have those happen to us? We can learn from them and have sensible governance if we are the ones to demand it. So I'm sure it's really obvious already how this is potentially a very impactful industry and how it can really change society as a whole. What I'm hoping is that now it's also clear how it can be a positive change if we're intentional about it. Thanks. If we have time, I'm happy to start a discussion or answer questions. Otherwise, also happy to have conversations in the hall or tomorrow, if people prefer. Okay, I must have just been really clear.